Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to answer the question that I know is just burning on your mind. What is a limit? Okay, so for this discussion, we're going to start with this function right here. And there's something that that you need to realize right away. All right, we've got this x minus 1 in the bottom. And remember, division by 0 is not allowed. We used to joke in physics, even in quantum physics, division by 0 is not allowed. Quantum physics, where it seems like almost anything is possible. But anyway, division by 0 not allowed. And that means that x equals 1 is not in the domain of this function. All right, so the domain of this function is all real numbers. It's defined everywhere else, except x cannot equal 1. Now, if we look carefully at this thing factors. The top of this factors into x minus 1 times x plus 2, I believe. I'm going to double check that. X squared plus x minus 2, yep. Okay. And you'll notice that these now cancel. So basically we get this, x plus 2. So this function right here is de facto a linear function, right? But it has this restriction in it because of the bottom, right? Now I'm going to go ahead and graph this. This is a linear function with a slope of 1 and an intercept of 2. I'm just going to do a quick sketch of this function here. Just, this is just a sketch, not a perfect picture, but good enough. Now remember, at x equals 1, it's not defined though. So if we said like, give me a minute to think about this graph actually. I want to make it a bit more realistic. Intercept is 2. I want to put this up higher. Okay, maybe something like this. There we go. And let's say 1, 2. Now right above this, the function's not defined. So basically what that means, there's a hole in it. So basically we're just going to put a hole in this graph. Now, what we're going to do now is kind of investigate here this hole. And kind of blow it up. I'm going to just draw this picture down here. I'm going to make the hole kind of large here, okay? Now, here's some things to kind of consider here. This hole, this kind of looks like it's got this finite measurable distance this way. It doesn't. This thing is infinitely small, okay? And the value here, like the y value, would have been y equals 2 when x equals 1. Make sure that's right. I'm sorry, not 2, 3. 3. But this is not part of the graph, okay? Now, so this thing right here is not part of the graph of that equation. Now, here's something to consider, though. It's all about, the limit is about what's happening when x approaches 1. So, this function is defined at x equals 0.99. You can get a number out of it. Now, I don't have a calculator here, but I would invite anybody who wants to. Well, actually, no, we can get a number out of it, right? If x is 0.99, then y is 2.99, right? And I'm just taking that value, subbing it in. Now, if you think about, let's get a little closer. Like, we're approaching, like, let's say here's the x equals 0.99, and then we move to the right a little bit more, where x equals 0.999. And you'll notice we can get a y value, 2.999. And then I'm just going to move this over here. If x now is equal to 0.9999, then y, right, you put that into here, is 2.9999. So the limit is the value that y is approaching as x approaches 1. And in this case, as x goes to 1, y is going to 3. Now again, f of 1 does not exist. Does not exist. 1 is not in the domain of this function. But we can still say that as x is approaching 1, y is approaching 3. And that's what a limit is. A limit is the value that the function, I'm just going to put f of x, approaches as x approaches, and I'm just going to shorten that, some value, some number, okay? And that, I mean, that's what a limit is. It's the value that a function is approaching as x approaches some number. And there's a little bit of language that kind of goes with this. What we would say here is that the limit as x approaches 1 of this function, I'm just going to put f of x here, is equal to 3. Now, again, f of 1 in this case doesn't exist. It's not even part of the domain of the function. So this is not a function value here. It's just the value that the function is heading towards as x approaches some value. Sometimes the function will be defined at the limit, sometimes not. In fact, I would say most of the time the functions will be defined, but I use this example to specifically show that it need not be. So anyway, that's a little bit about a limit and what it is, and I think I'll start making videos about how to calculate them. Have a great day.